In this video we're going to go over how to get from Revit into Ecotect and how to run a acoustical analysis on a simple room. So first thing you have to have set up is you have your simple Revit model. You have a room placed in there that does touch all of the surfaces you want to analyze. You should also make sure that your room is working in 3D for the volume of the space. So to do this, make a section through the building by going to View, Section, and you can draw a section just like this through. And when you double click on the head of that, you'll need to set it up to show the interior fill of the room like this. So to do that, you would go to Visibility Graphics, scroll down the rooms, and make sure interior fill is checked. And what that does is it shows you where the room is in 3D. And you can see this is going up to the bottom of the deck above. If it's not, and it's stopping short, make sure to go to the Architecture tab, Room and Area, Area and Volume, and make sure it's set to do areas and volumes, not just areas only. Areas and volumes will allow you to control the height of the room, and it'll also allow it to stop at any room bounding floor or roof above. So you can see in the properties of this floor, it's room bounding. And that's it for the Revit portion of this. Now we're going to export out this model into an XML file that Ecotect can read. So to do that, go to Export, and you're going to it calls it a GBXML. That's a green building XML file. It's really just an XML file. So if you click on that, it has some settings for export complexity. We're not doing much with solar shading or anything on this, so we don't have to worry too much about the exporting of the complexity of the model. Just make sure when you export under details, you don't have any exclamation points next to rooms. What that means is you have some airspace in there that's causing problems, and the room is not complete in the space. If that's the case, work with your walls in your room to try and stretch them out and fill the space completely. So hit Next. We're going to export this out. I'm just going to save it on the desktop here. See, it's just an XML file. Alright, and that's it for Revit. Now, the next thing we need to do is we need to go to your computer's notepad. This is something that changed in right around Revit 2012, 2013. It changed the XML file format, and the only way to make it work into the older Ecotect 2011 is to change the format of the XML file. So go to File, Open, and make sure you have it set to all files so you can select the XML file, open it, and then we're going to go right back and Save As. And the only thing we're going to change is the encoding. We're going to switch it to UTF-8, the older version. Save. You can save right over the other file. That'll be okay. And that's it. So now we're going to switch over to Ecotect. And we're just going to go right to Import and Model Analysis Data. So there's two ways to do it. You can bring it in by the room in the XML file we just exported, or you could bring in pieces in as 3D geometry, and that is just a DWG file. It's good to do it to start your model with the room and the analysis data because it establishes the room for Ecotect so it knows where the room is, where the boundaries are. Then if you need to add anything more complex, you can model those separately in any other program, export it as 3D CAD, bring it into Ecotect, scale it, place it, put it where you need it to be, and assign materials. In reality and Revit, don't do too complex of a model because it's not going to come through. It's only going to come through with the surfaces that the room is touching. It's not going to come through with clouds and any kind of acoustical device hanging in the room. You have to model that separately. So for here, we're going to bring it in model analysis data. Again, make sure to show all files so you can find that XML file and hit open. So it found the space. The room becomes the space in Ecotect, and rather than having to create a space in Ecotect, it's much easier to bring it in like this. So you could see it's guessing the different types of elements in the room, and it gets, for the most part, it gets them right, but there's a few things that we're going to correct, such as the door. We're going to click on guess and say you're a door. And for the mullions, they're on the curtain wall. For now, we're going to tell it that it's walls. You can always come back and change all of the surfaces and their materials in a minute. So we'll open as new. And here is our room. You can rotate with this little command here. We're in a perspective view right now, but that's the room, or what is now called the space in Ecotect. Alright, so the first thing we have to do is come up here to your zone management, which is this button here, and we don't need external shading. So the external shading is more for if we're doing a sun study or an energy analysis. We don't need that. So just right click on it and say delete the zones. Yep. And what that did is it just simplified your model to all of the planes of your room. So it's now simpler and more easy to manage when it comes to doing it. So now we're going to work with the materials in this project. What you can do with the materials is it's this checkerboard button here, and whatever you click on, it'll tell you what its material is. So oddly, it makes all of the walls in the project a brick timber frame construction, which isn't accurate for this space. So rather than clicking on each and every single one of the walls, the easiest way to start making big changes and then you can come back and refine them is to use the select tool and select by element type and say you want to select all the walls. Now once you have this selected, instead of brick timber frame, which this is more like drywall in here, you can go to framed plasterboard. And to add further information, you can double click on that, go to the acoustical properties, and make sure it is set up the way with the properties of the element that you want to analyze. So make sure this is all lining up with what your textbooks say gypsum wallboard should be. You can always create new elements, you can always create new materials, and add more information into this library and reuse it around the project. So this is now all framed plasterboard. So you can go around, select everything. You can say it's a concrete slab on the floor. You'll see the material assignments change with this drop-down menu for the different parts of the room. And you can always select something to be more accurate. Same thing. You should have every surface, including a ceiling, in here. And again, you can select by element type and say I want to select the ceilings. Get the ceiling. Right now it's saying it's a concrete slab up above. What we'll do is leave it like that, but then we can always come back and change it to acoustical tiling and see what changed with all of the different analysis and your reverberation times. Okay, once you have your materials set up so that they're close for at least the first test, let's figure out some reverberation times for the room. So to do that, you can come up to the Calculate tab up here at the top, click, and we're going to go down to Statistical Reverberation. You can hit OK for the recalculation. You can see it's running down here and giving you a percentage update. Once it's done, we're going to make some adjustments in here. We're going to hit recalculate so it determines the area of the room. We're going to put in roughly the amount of seats that we think will be in this room at the time that we want to run the test. And you can select the type of seats that are going to be in there, because all of this will affect the amount of absorptive material in the room. And it's trying to get an understanding of what that is. I'm going to change my reverb algorithm. And you can see here we get our reverberation time. As you can see, the volume starts by default in meter cubed, meters and surface area metered squared, just so we can have the English system. Go up to File, User Preferences, come to Localization. Make sure your model dimensions are feet and inches, and your general is set to US standard. You'll see it changes to feet and square feet. You can apply it to all sessions and hit OK. And you'll see that all of these update down here. If you find that your graph comes along and drops to the bottom of the chart in flat lines, that is because you have a speaker in the space that's throwing off your reverb time. And what you can do is just make sure to select that speaker, come over here to the zones, and put it on a different zone, and then turn that zone off. And what that would do is allow your analysis to work without the speaker in the space throwing off your reverb times. All of your results will show up down here. If you scroll down, you'll see the optimal reverb times for speech and music. You can see that they are different. And then if you come down, you will see with the different algorithms, the different reverb times for the different hertz. And you can see we have some pretty long reverb times in here. So this room really isn't very well suited for speech or music as set up with all of the hard surfaces in it. So that's when you can go back and start working on getting a better reverb time for the space. You can see it in all of the different frequencies. The next thing we're going to test is we're going to test how sound moves in the space. So what we're going to do is go back to the 3D editor tab on the side here, and we're going to place a speaker inside of the room and how it projects out in the room to a different area. So if we go to View, we can go to the Plan View, see the room in Plan, and you're going to come over here and click on Speaker. And we're going to aim it. The first click is where the speaker is standing. This could be a person standing, or it could be a single speaker in the room. And then next is where it's pointed. So we can point it this way and plan. And what we also want to do is move to a side view and make sure the speaker is at the right height in the room. So I'm going to go to View, and I'm going to go to Side. And it's on the floor, which is probably not correct. So if you get lucky, you can click on it sometimes and just get it. Like I'm getting it there. You see how it highlights. A lot of times you're going to try and click on it and you're going to get the wall behind it or something else. So what you can do is come up to Select by element type, and do a sound source. And we only have one in here right now, so that gets that one speaker. Then come up to your Move command, and you can move it up. And you see it's going up 5 foot basically here. You can also, if you click enough at one of the points, let's see if I can get this to go, you will get a little red box. And what that means is now you should be able to move that box with your mouse. So now if your speaker is going up or pointing down, you can make a slight adjustment for that. So I'm positioning this as if it's a person talking in the room in one direction. So we can flip back to the perspective view, and you can again rotate using this button. And Now what we're going to do is we're going to do some analysis on how the sound moves around in the space. So go to here, go to this little particle image, click on that, and what we're going to first do is do reflector coverage. These are all just different ways of displaying how the sound is moving in the room. So click on reflector coverage, and what I'm going to do is increase the amount of rays for this one, since this is just going to be making points, and the more points you make, the easier it is to see. I'm going to reduce the bounces to 4. I'm going to set this to be 500 Hertz, just similar to the reverb times that we were looking at. You can set it to the different frequencies and get different results. And then we can just generate the rays. And here you'll see where the direct sound is hitting and where the mask sound is hitting. So the mask is more at an angle and coming back. And mixed in here, there's some yellow. It's hard to see, but that is also direct sound. You can also change the spread of your speaker and make it a more direct sound, going in one simple direction, and then generate rays again. And you'll see that that's more direct, and you can more clearly see where all of the direct sound is going. It's hitting basically these two walls. The reverb is one of the bounces is hitting here, spreading out on the floor, and the masked is where you're going to have the sound bouncing around, and it would have made several bounces by the time it was gotten here, and it would be very unclear if it's a person talking. There'd be a lot of interference in this area. There's two other settings to see how the sound's moving in the space. This makes a very clear diagram, and at any time that you make a diagram with the settings that you need, you can always come to File, Export, and export an image or screenshot. You can actually also just use the snipping tool and do a print screen of the view, because that is basically all it's doing when it's exporting that out. So what we're going to do now is we're going to change this to show the sound rays bouncing in the room. So to do that, just going to go to Animated Rays, and I'm going to really reduce the number of rays. I'm going to go all the way down to like 20, just for now. And we're going to hide any rays below 60 decibels. So generate. And there we see it bouncing in the space. And generate again. Sometimes you'll find with this old program is that it gets the colors wrong. So always pay attention to what's actually happening with the sound in the space. For example, here the legend says direct is green, but actually in this diagram direct is magenta. And so you can see I have to regenerate every time I move it. But you're seeing how it's bouncing. And really after a couple bounces it becomes very masked and hard to hear. So you're looking for more direct rays and where they go. You can also always adjust it to only do one bounce. And that way you get very direct sound and where it goes. And you can see it changes slightly, because since we only have 20 rays here, it's not getting complete coverage. You can always bump that up to 100 or whatever you want to do, just to show clearly how the sound leaves the speaker and where it goes. You can look at it from the side. And then you can always add a second bounce. And you can see where the sound starts crossing the crowd and coming back. And then one last thing you can do when you're analyzing this is you can do animated particles, which is fairly fun because it will actually show the sound moving in a little animation, and it goes really quick. So animated particles, let's show the fat particles, and we have to make a lot of them to see them. So I'm going to do like 7,000. I'm going to click generate, and you can see them spread out through the room. And here they go. They're going to bounce off the wall. There they go, and come across. I'm going to do that again. So this is the direct particles in the room. They should be green, but they're showing magenta. They bounce, they become echo and masked, and cross the room. And that's only 2 bounces that I did. So we can always go with 3. Makes the computer think a little bit more, but shows you a little bit more how the echo happens in the room. And that gives you an idea how sound moves around in the room. And that's how we would do it with Ecotect in a very simple way.